All right. Guess we'll go ahead and get rolling here. Looks like most people are back from where they were. The next session we've got going on is the discussion around the ongoing Accelio RDMA messenger work being done by, looks like Matt and Eyal were the blueprint owners on this version this time around. Matt, I think you're in by phone, so if you want to go ahead and give us a little bit of an overview. Those following along at home should be able to take a look at the pad. He's already got a pretty substantial outline of what's going on of the status. So, Matt?
Yeah, to unmute, I think.
Yeah. Here, I'm just going to unmute you. You with us now, Matt?
I am.
There we go.
Cool.
Is Eyal present by any chance?
What's that?
Is Eyal present? I was not sure whether he was planning on being.
Don't see him. It's NRC.
I haven't seen him in either location yet, no.
Okay, well, if I can do the basics, I did. I put an outline of what I can speak to briefly in the pad. I was hoping for a little bit more feedback from the Mellanox folks about what things are being added to Accelio, but the basic points I wanted to hit here are new things that Accelio is doing, some new things that Accelio Messenger is doing, where we are with different pieces, and sort of questions based on that. So starting with the Accelio side, and if Eyal joins, he can bring in more feedback there, or more data there. Work has been ongoing over the last several months to add multi-transport support, and the TCP transport is becoming more full-featured. We're also working on new explicit flow control interfaces within exposed through the Accelio API to enable applications to get more control over resources Accelio consumes, but also to get features similar, like Ceph's throttler to tightly integrated with Accelio's workflow. And they've been gradually fitting in different RDMA memory models and transport memory models and buffering models into view, and that intersects with us. So I won't go into too much detail over there, but suffice to say, there's various ways to do memory registration or to avoid it, and the strategy that the system takes to decide when to use RDMA send receive and when to use RDMA read or write. The latter of sort of requires registered memory and so on. So switching to the Accelio Messenger review of that, we just got done with major refactoring of that aspect of the Accelio Messenger. What we had found is that the model we were using, which was delegating to a lot of that detail to Accelio, meant that we couldn't return Accelio messages, the basic sort of message objects to Accelio until we were done with all the buffers that had been associated with that message, which meant that which mixed imperfectly with the way the rest of the Ceph environment shares buffers by default. We came up with a way around that, which we called strong claim. But we wanted to especially Mellanox wanted to use the opposite model by default. They wanted to consider that to allow sharing by default, and we also found that we could by doing that we could release messages immediately. So which would make Accelio more efficient.
So let me just clarify that. So that means that the memory buffers that we're reading data into off of the network, where the RDMA data is actually landing, are you're trying to use a model where that memory could then be referenced by buffer list and used throughout the rest of the stack, and without being owned by the Accelio library. Is that what you mean? Can you
Yes,
just
it
sort
is.
of clarify what the life cycle is there?
Yeah, of course. The idea is that if a buffer is the buffer may be registered, might be registered or not or whatever, but as it was with the model that we used, Accelio essentially has to the memory buffers we were using were linked to the requests that the transport requests that they came in on, the message they came in basically, and that in that model we couldn't retire some fairly heavyweight Accelio resources until substantially later, potentially.
Until all the buffers went away. Basically.
Pardon? Yeah, that's right.
Until all the buffers. Okay.
And there was some extra overhead associated with it too. Not only that, the synchrony required for that could cost relatively little in terms of the fast path, but it put a lot of load in the slow path. So we had these asynchronous completions that fired eventually, and burned extra CPU. So getting rid of that means it produces a new model where we still use the same lock-free memory primitives that Accelio provides, but the application provides all the buffers, and therefore they can be returned to those pools whenever. I went ahead and blended in the claim idea also for places where we explicitly think that it's likely that we'll keep a buffer around for a while, and maybe it's a small buffer, and we may as well dupe it. And for example, there are a couple of current cases that I think are candidates for that in the Ceph code, like when we're building up an OSD map or one of the other cluster maps. These buffers may live for a while. They're not gigantic memory map buffers, and returning them faster would be cheap. But anyway, the new model is we have pools of pre-registered memory. This is a common model in IB verbs programming. These pools could be very, very large if needed. Potentially they need not be. But the buffers are pre-registered, so actually registering the memory is a somewhat expensive operation. We've already done that on these. We associate those when in a pre-RDMA read step that's orchestrated by Accelio, and then a couple microseconds later or whatever, we decode the message and hand it off. The Accelio the Accelio message structure that those sort of low-level message structures that we frame on datagrams for Accelio, we dispose immediately. Then the Ceph message just goes off the way it normally would. When each buffer is unreferenced to the last time, we return it to the pool at that point.
Mm-hmm. Is there an issue with exhausting that pool, or we have to worry about the number of buffers that are floating around?
There's definitely it's definitely the new theme. Yes, is to manage that resource. But we speculate that's manageable, and we've got some outstanding. We've got some debug hooks and outstanding message memory or pool objects tracking that we're using to figure out how that's going to work.
So what we did in the past with the existing messenger is that when we have incoming messages, we're using a throttle that basically keeps track of all the memory that we've allocated on the behalf of incoming client I/O. And if once that you hit a limit, you essentially just stop reading off the network so that we can bound the amount of memory resources that are consumed by clients throwing I/O at you. Is that the same type of model going to work where that'll in turn, I guess you'll exhaust those, would you simply exhaust that pool and so incoming I/O would block because there was no available registered memory or something, or how's that going to work?
Right now the pools are shared because I think this is an area where we're generalizing this and calling this flow control. I mean, Ceph has some good interfaces that we want to try to implement for that. It won't work exactly the same way. It's likely that in some future past we'd like to leverage Accelio for this, but Accelio already exchanges credit data, so it has receive side flow control. That's explicitly shared across the link. Ideally, we would expose that to applications. If not, we would likely build that into the protocol above Accelio. It's not exactly the same as being about the amount of memory that's in use, but it comes basically the same thing as we have a now sending message budget. Now there's a message budget that's a baseline message bill that's already established, and that does exist. That's like you said a queue depth basically, which is the same, which is basically that budget for each connection. And yes, if we exceed that, Accelio won't deliver any more messages until we've recovered it.
Okay, as long as that queue depth is not just number of messages, but also number of bytes.
Yeah, it doesn't currently have there's no equivalent currently to byte throttle. So we'll have to look at that as a follow-on thing. And
yeah, okay.
We understand this is the large management problem past this. At least I certainly do, and we're trying to adapt, ways to handle it.
Yeah. Okay. Okay. So you were talking about.
Right. So we finished this refactoring that does this. We just got to a stage where it now runs the entire cluster again, and so we're sort of in cluster testing. We've also ported it to a couple of internal branches, and we're pounding on it that way also. There had been a second branch called Exio Giant, or I guess Exio was called CMake-Giant or Exio or something like that, Giant, which we had pulled up to Giant. We have yet to do that. We want to do that at some point shortly. There's one outstanding piece in order to do one piece missing at the protocol level probably is fast dispatch. If we have those two things, once we beat out things enough to know that we have a good stable basis for this type of testing, we think we'll be ready. We would hope to be ready for some kind of pull request that would be conditionally compiled, so folks can run it at this level. Then we have new session management work in progress that goes past that. That I hadn't pushed yet. It was sort of blocking on stabilizing things, the stabilizing branches. But there's a prototype that implements all the remaining messenger interfaces except the throttlers. Those aren't explicitly handled yet, meaning it has markdowns, and it also adds the long-term sequence numbers that messenger has, and the restart callbacks and related interfaces are implemented. It does challenge response, basically following the same model that the Ceph messenger protocol had done, except it exchanges messages to do that. So it ping-pongs a series of messages until it reaches an initialized state, or else it fails. But if it does, then it's exchanged an authorizer, and so it should be possible at this point to use Ceph X as well as everything else. But it reduces the size of the messages we're sending across for other messages, and as well, because we currently kind of fake some of that. This is the Ceph X piece. We have no idea whether that's useful for RDMA. Some people don't think so, but in theory you could use it with the TCP transport. So it seems like it makes sense.
Yeah. Okay.
So there's a more or less code-complete prototype. It needs more work to be sort of attractive, but it is beginning to work. And that would be sort of I think the main thing we would like to contribute to this H release. Future stuff, as you stage, so the big feature we think is flow control stuff, and we'd like to have the most visibility, the most sort of sharing of workload between the most visibility, I guess, of a common model inside of Accelio. That's what Mellanox would like also, and they're actively exploring that. I think I think byte throttler for example, the memory budget might be something that Accelio never really knows about because we're explicitly decoupling that. But I think the message budget ought to be tightly coupled with Accelio, and that's kind of the direction things are going right now.
Okay. Yeah, as long as there's something that slows you down. This is one of the early problems we had way back when, was just eating up all the memory on the server.
Both are necessary. Yeah, without that, everything goes down a raffle real fast.
Yep. Yeah, it doesn't take long. Okay. Okay, so I think that the biggest questions for me are really about how we sort of get this stuff integrated. So I can give a quick update on this end. Mellanox sent us switch and some cards, so we'll have some RDMA hardware in the lab,
Cool.
which means we'll be able to, once this is in, we'll actually be able to run regular tests against it. The other thing though is that now that Accelio has TCP transport added, we can actually just do that on regular hardware and test most of the same code paths.
Yeah, that's
Obviously,
right.
won't exercise the RDMA stuff, but it'll get some coverage. So that'll be helpful. But I think that the key thing is how to get this into state where it's ready to go upstream. I think that there are a few different places where this sort of this breaks down into. So one is the buffer management stuff, all the bits that integrate with the buffer code need to get integrated in a way that is sort of non-disruptive. You've mentioned a couple of times that there's been a bunch of stuff that you've played around with the buffers. Is the Accelio memory management stuff, is that particularly intrusive?
No.
Or
so that's good news. There is no. I mean, the way we've those we can compose them together, but basically there's about, I don't know, it's like 25, 30 lines of new buffer logic that goes with Accelio. Maybe it's 40. But I mean, the basic one is just an Accelio mempool buffer type, and it's which is basically linking it to the mempools. There's a small change that originally was intended to be intrusive, but it's not now. That this lets you that adds a new virtual method to raw that's only Accelio that's only really interesting for Accelio, but it's the strong claim concept. That's the idea that if you have a buffer type that would rather be cloned in response to some higher level goal, then it creates basically a new basically memdubs these and returns the Accelio buffer. We thought this would be useful for, as I say, cases where we know we're putting a small buffer or a set of small buffers someplace where they're not going to be returned for a long time.
Okay.
But again, that's not intrusive. So that's the sum total of what it needs.
Okay, that's good.
The latter case,
that's good news.
Yeah, frankly, I think it's a good idea to have it.
Is that strong claim something that the sort of higher level logic needs to explicitly enable, or is there something that decides it wants to do that at some point?
Well, this is historically we came up with. Initially, I strategized we strategized over here about having that as a way to deal with the previous model where we wanted to block sharing in the unmarked case. So that would have had a performance cost. So in that version of the logic, which you can read it if you want, it's out there. It does things. It decides, basically we explored the possibility of making essentially all sharing do this by default, and then make sharing the marked case instead of the unmarked case in buffer. But this change is not doing any of that. It's just saying basically cow the buffer. If you cow buffers through some obvious interfaces if we're grabbing something and we don't want to, and we're explicitly aware that we don't want to hold volatile memory basically. So you would have to do it. Otherwise there's no.
Okay. Yeah.
So the other, so going back to as far as getting this code upstream, it feels like there are a couple of things. So one is making sure that the buffer code, the generic buffer bits are in. That's pretty simple, I think. There's still the build integration. Just we're still using Automake, so we need to futz with all the Automake config files so that there's a enable Accelio thing that does all the library detection and defines the right things properly.
Sure.
So that this is conditionally built. And there's the Accelio library itself. I don't know how you guys are building or distributing it. And this is where I'm going to set up red flags for Danny. But that is the idea that XIO is going to be packaged independently, and that we would dynamically link against it, or are you using this as a statically linking it in, or what's the plan on that side?
Both are possible, but initially, basically, I can just say what Melox wants to do. I mean, they like linking dynamically.
Okay.
And therefore, we've been doing it that way for the last while. And so, second of all, there's that Accelio code is moving quickly, and I don't know about any plans to integrate it into distributions or places like that. So
yeah.
So getting it and getting the right branch of it at the right commit is a problem that we need to solve. And I would have said in the past that we would use a submodule might be an appropriate way to do that.
Mm-hmm. Yeah, I mean, just for practical purposes, that makes it really easy to make sure you're using the right version. Okay. Well, I mean, maybe the strategy here is to do the same thing we did with rocks, where there's a with static XIO and with dynamic XIO type options, so you can do either one.
Sure. Yeah. I actually like linking, static linking for this, and we've done. We initially I did everything with that. So both will be acceptable. But I think once you can agree on the canonical location of the code, there's an official Accelio GitHub that has all their published branches and everything. And it'll just
clone that as a submodule.
I would assume that's I think I would recommend doing that, and I think that Accelio will support that.
Okay. Yeah, that'll let us test it on multiple distributions without having to build a bunch of packages, which is not what we want to do. Okay, and then there's just the messenger bits itself. So you probably noticed this when we merged the async messenger, but we split up the message subdirectory. So there's a explicit subdir for all the different messenger types. So there's a simple directory and an async directory now. So I assume it'll be pretty simple for you to put your code into that format. And then the only reference in generic code to the messenger then is just in the messenger.cc create factory function that just instantiates the messenger. And there's a config option that does it. So in the past, your early branches had a whole bunch of changes to all the other bits of code to create different messenger instances and stuff. Have you cleared all that stuff out now? Is any of that still necessary for other reasons, or?
I think we've had branches that cleared all of it out. We in other words, for our stabilization, we haven't taken it out. We're just trying to stick with keeping things as unchanged as possible. As few changes as line as possible. So we'll have to. I assume I don't know of a reason why it won't work. So we'll have to pull it up and sort of retest it.
Okay. Okay. So needs to need.
I'll certainly help with that and try to make sure that it.
Yeah, I think the other thing right now is that right now the factory function, the factory conditional based on gconf ms type or whatever. But that probably needs to change so that the caller is passing in the messenger type it wants to instantiate, so that you can, have the messenger, for example, could use one on the back end and one on the front end or something like that if we want to support that sort of thing later. But
yeah, that gets maybe segues to the other question that we haven't made a lot of forward progress we were interested in, but haven't had time to really look deeply at the sort of addressing problem. It's really important to the functioning of the be able to name the endpoint by its address and listening port. We have a sort of a hack that deals with that, but especially if we're going to have different nets using different ones, we would want to have control over that.
Right. Yeah, that's going to get tricky.
Something that we plan to work on over the next while. But I don't have a full, early well-defined timeline for when it would work.
Yeah,
we could discuss requirements for it in more detail. That might help.
Mm-hmm. Yeah, it's a little tricky because on the client side, you want to be able to sort of use whatever transport is in use on the server side. But it doesn't really break down that way. I think for the time being, it's just going to be that for any particular plane of the cluster or whatever, there's going to be a single networking type used, at least for the time being.
Okay.
But probably the simplest thing at this point, though, would just be to change the entity attrt type field to have an XIO type. But still store a stock adder that is identifying the endpoint. But the address type would actually be typed, so you know the endpoint was a XIO endpoint. And for now, I think your messenger would just sort of assert that was true. But in the long term, eventually be able to sort of dynamically behave based on that, probably. That should work. Okay. But I guess the biggest thing though is just pulling up all the current code to Giant and sort of carving it up in pieces that we can merge. So I would probably do it in this order. So initially do a patch that just sets up all the dynamic linking build stuff with the submodule or dynamic linking to the library, that bit, and then the buffer management pieces that are conditionally build if that's turned on, and then adding the messenger type piece.
Yeah, that makes sense.
It needs to be based on master, right?
Yes, of course.
Before that. Yeah. Okay. Okay. Do you want what kind of timeline you're looking at? I mean, is this going to fall into the Hammer timeframe of a January 1 freeze date?
Certainly that. And
Okay.
I'll try to prioritize getting a pull request in the next week or two, if that works. I don't know if it'll be ready, but we'll have all the pieces for pull-ups.
Yeah, and the sooner the better, definitely, because we can. It inevitably takes a while to get all the testing stuff sorted out.
Well, I'll package up pre-commits on master that aim to do those 3 steps and get them out there.
Cool. Okay. Okay. I guess while we're talking about it, I'd take just a quick minute to talk about the other messenger, the async messenger from Helm at United Stack. We merged that. It's disabled by default and has been tested sort of externally, but we haven't actually run any tests in the lab yet. But all the pieces are there to actually do that. We just haven't done it yet. So I think probably what we want to get towards is it would be nice to have a test suite that just exercises all the different messenger implementations with some similar workloads that stress test just the networking layers. And then eventually in our other test suites, we could have the config sort of randomly pick different messenger types. And so we get just general coverage of the implementations. So I think that's the general plan.
What kind of testing do you think we're going to get out of the messenger suites? Because
yeah,
I mean, I say that sort of most of the difficult bits are in terms of reconnects and things, which we aren't going to get without,
happen.
crashing.
That's kind of the problem. But at the same time, I don't want to explode the current suites out with by 3x by saying run this on every messenger. I want like a constrained thing that will sort of focus on just ones that are doing as much failure injection as possible with some maybe OSD thrashing and lots of clients and I don't know.
Well,
lots of
presumably we could just like rotate them on the nightlies or something then, rather than exploding them, because
we could.
Those are a lot more stable than most of this stuff. But
yep, we could do that too. But still having a collection that is as much stress on specifically the messenger would be helpful. I mean, ideally, I think it. So the simple messenger and the async messenger are protocol compatible, and the XDR one obviously is not because it's not. But at least for those other two, it would be ideal if we could eventually get to the point where the messenger implementation is just randomly chosen for every run or something, so that we just have a broad spectrum coverage for both of them. And then in the XIO case, we'll have to be more careful. I mean, we might be able to do that with the TCP one at some point, although it'd have to be the whole cluster is running that one implementation, not just a random subset of the daemons. But I think it'll take a little bit of. We need to make sure they're really stable before we start mixing it into all our current QA, adding a bunch of noise. Okay.
I'll wrap that one up.
Yep. I think so. Any other questions on? I didn't look at IRC.
Nothing there.
On IRC or nope. Okay. We're in the session.
All right.